It's told in textbooks and in many videos in Wikipedia that self-inductance EMF appears in a conductor as force opposing the change of current in it. But here you see the oscillograms of the experiment when self-inductance EMF is directly shown, and it appears when there is no current at all. So the question is, how self-inductance EMF appears when current is zero? How can some magnetic field cause the self-inductance EMF if there is no current yet to create any magnetic field? So the self-inductance EMF is a very interesting subject. It's kind of a mysterious subject, and this experiment will show us in a very practical and easy way how to see this EMF directly, not with the help of current or help of some magnetic fields or something else, but see it clearly and directly. So let's start. Self-induction EMF. How can we see it directly? This is Sergey Deyna's experiment Replication, the only explanation for this moment. So please, if you know some other correct and practical explanation, not theoretical, the theory can be wrong without a practice, but a practical experimentation. If you know some other explanation, please let me know, write a comment. This is the most mysterious place in the experiment for which this work has been done. Nobody knows what physical process stands behind it. Sergey Deyna. This is a quotation from the original experiment. How can it be that nobody knows what physical process stands behind seemingly so well-studied element as an induction coil? A mystery attracts people, and I am not an exception. Exactly this phrase brought me desire to replicate this experiment. It was the first experiment that I did after the decision has been made to understand better electronics and check by myself if all the information given to us in textbooks is correct and real. Before that, I was only constructing different devices with already done schematics. But engineering and design require a different approach, especially it's true for power electronics and energy research. Sergey Deyna's channel has plenty of videos where familiar phenomena are investigated from non-standard positions, or attention paid to some details which can open new understanding. It turns out that not everything is understood well, and not everybody understands it. I'd like to recommend these experiments for everyone who really wants to understand clearly how induction coils work and go beyond stereotyped conceptions about it. I think it's necessary if you want to move forward on the path to the energy of the universe. So you can find original Sergey Deyna's video experiment and instructions with these links. The text version of this work you can download in description below this video. All the links will be here. So this is link to English translation of this work. It is in my channel, Life Science. You can check it too. You can download and read it, not just listening to the video, but read it by yourself in your computer. So next, the goal of this work is to replicate the experiment, confirm or disapprove the data received by Sergey, to explore transient processes in a series LC circuit, especially at the moment of closing a circuit consisting of a voltage source, an inductor, and a capacitor all in series. What about the title, Self-Inductance EMF? Sergey paid attention at the beginning of his video that this title does not mean what is supposed by conventional terms. This fact makes this experiment even more interesting to find out what physical effect was called so. At the same time, he added that very important things happen there, if not to say the most important things, especially for those who are interested in building fuelless generators and seeking for so-called free energy. Although many could consider these things insignificant and that there is no need to investigate them. So next is the description of the experiment. The goal, quoting original. The goal of the experiment is to show that at the moment of closing the circuit consisting of the voltage source, battery 1, so you can see a scheme of this experiment. So battery 1 is here, the inductor L1, the capacitor C1. At the moment of closing the circuit, self-inductance EMF appears in the inductor, while its magnitude being equal to the source voltage, 9 volts, the polarity is opposite. The capacitor is charged double the source voltage, 18 volts at the end of the cycle. So you can see the relay and generator. This relay is closing the circuit intact with the generator. It will be description of this system below. We can see the voltage source, 3.5 volts battery in my case, the inductor and the capacitor being connected through the double-throw relay in series. This relay closes the charging circuit first and then discharges the capacitor to itself, intact with the driving generator. With this operation mode, we can interrupt the process in the inductor at any moment, and by then discharging the capacitor, we can repeat this process with any frequency we need. Sergey called this mode Stroboscopic Mode. Such feature of the scheme is delivered by a device called electrovibrator. It is a special relay with one moving and two stationary contacts. Moving contact is moved by electromagnet. It's easy to find this type of old relay used in vacuum tubes converters, or use double-pole, double-throw relay. The same result could be received with properly tuned solid-state switches, for example using fast IGBT. So in his video Sergey showed his device, and this is the one I used in my experiment. So on the photo you can see this relay. This is a circular electromagnet. In the middle of it is moving contact. So to the left and to the right it's stationary contacts with tuning screws to set up a duty cycle for each of the contacts. The author of the experiment suggested to interrupt the circuit at the half period of the oscillation in the series tank LC circuit formed by L1 and C1. Then he paid attention to the fact that at the moment of closing the circuit, some voltage equal to the source voltage appears on the inductor L1, while the current in the circuit has even not started. In this work, exactly this phenomenon is considered to term self-induction EMF. Then, the current slowly rising. After 1/4 of period it reached its maximum. The voltage on L1 is 0 and the capacitor C1 is charged to the source voltage value. After the 1/2 of period, the current decreases to 0, the voltage on the capacitor increases to double the source voltage, and the voltage on L1 reaches the level of source voltage. Of course, we have to take into consideration active losses in conductors. They cause the voltage on the capacitor plates to be slightly less than doubled value of the voltage source. Next, in red color, you can read the comment given by Sergey, the author of the original experiment, while editing this work. Sergey emphasized the key points to which we should pay main attention in this experiment. You should obtain a result like this. The relay circuit is not shown. Consider that oscilloscope's probe tip and ground can be interchanged. That's why the polarity of the voltages can be different on different diagrams, but the polarity of self-inductance EMF never changes. So attention should be paid to how probes are connected in every particular case. Below are shown two stages of the process in series LC tank in 1/2 of period. On the left is the moment of closing the circuit and connecting the tank to the source of EMF. On the right is the moment when capacitor charging is ended. So you can see the battery having such polarity, 0 volts on the capacitor, and when this switch closing on the inductor appears some voltage with this polarity. When the capacitor on the right image is charged fully to the 18 volts, when the battery is only 9 volts, The polarity of the inductor changes. You can compare it to these pictures. For clarity, let's remove from the left picture all the details that are not related to the phenomena and transform it, considering that in the moment of closing the circuit, we can interchange the capacitor with a wire jumper. Let's call the moment of closing the circuit starting of the charge. So this is simplified pictures. We can see on the figures above that in the process of charging, the polarity of the inductor and the capacitor changes. Figure 3 shows the end of the charging of the capacitor, but in the beginning of it, the voltage on its plates was 0. Figure 1. The voltage polarity of the inductor looks different in Figure 2 and in Figure 3. Why? To this question will be dedicated my second to last works. Here Sergey means his works from the series Physical Meaning of Current and Voltage. For example, this is a link to the work Why Capacitor Has a Dielectric. This work is in Russian, and I hope the English version of these amazing explanations will be available soon. So next are the author's diagrams and commentaries from the original experiment. So this is a diagrams which is based on the oscillograms Sergey received in his experiment. So the top diagram is closing relays contacts. So here is the closing, this time of closure, the opening. So next is charging capacitor curve. You can see the UAP. This is the voltage of the source, and you can see that capacitor is charging double the voltage. Next in blue color is voltage across the inductor. You can see that on the moment of closing it's negative, then it crossing 0 and becomes positive. The last one is the current in the circuit. So the description. The duration of closing the relay is shown on the top with brown color in the form of square impulse, during which L1 and C1 are connected to the voltage source and charging of the capacitors occurs. The same amount of time the capacitor has for discharging. And the discharging process is not shown on these diagrams. So the next diagram shows with violet color the capacitor charging. Its amplitude reaches the value double the source voltage. The diagram of the voltage change across the inductor, UL, from -9 volts to +9 volts is shown next with blue color during the whole period of the capacitor charging. This is the most mysterious place in the experiment for which this work has been done. Nobody knows what physical process stands behind it. The last diagram shows the change of the current in the inductor, during which the capacitor C1 charging occurs. As we can see, at the moment of closing the circuit, the current in the inductor is 0, as it should be according to the theory. Then the current starts to rise sinusoidally until it reaches the maximum IL, then it decreases to 0 again. Pay attention that in the moment when the current in the inductor reached its maximum, the voltage across the inductor was 0. All this is totally in line with the electrical engineering theory where the oscillations in the LC tanks are investigated. It is seen that voltage in current phases is shifted and the current is ahead of the voltage on 90 degrees. I'd like to add that there is some spike in the inductor voltage diagram at the moment of closing that goes a bit lower than UL value. So here in the diagram, this spike is here. Zooming the moment on my oscilloscope screen, I get this picture with no such spike. Later, Sergey explained that this spike on his oscillogram was due to the mechanical contact bouncing, and with some tuning of the relay it can be eliminated. Okay. And yet it's interesting to understand the picture on my oscilloscope. What are these secondary oscillations with frequency about 6.2 kHz before and after voltage rise? How the oscilloscope is related to it. So next is a replication of the experiment. So real oscillograms, scheme and circuit of this experiment I have done a year ago is on the photo next. So the first is the charging of the capacitor. The second is voltage across the inductor. And I have used a DC mode on the oscilloscope. Sergey used AC mode. We have a bit different oscillograms, but the logic and the result is the same. You can see that this is a 0 line. This line is 3.5 volts of the battery, and here's the moment of closing. The self-inductance EMF cancels the EMF of source voltage, cancels it totally. And the last one is the current in this circuit. You can see that current is 0. There is no current, but self-inductance is present, and self-inductance in such magnitude that it cancels totally the EMF of the voltage source. From where it came, the question is. So the scheme of my experiment are the connections of the oscilloscope, the photo of the circuit. In my measurement, in my case, measurements was done in DC mode, using different principle but with the same logic. In the original experiment, Sergey used AC mode. This point was confusing for many of viewers, and Sergey had to film 2 additional videos to explain it in very detail. I recommend to check them if you have some doubts about measurement procedure. So addition number 1, addition number 2, addition number 3. This is the link. Attention should be paid to the addition number 3, because there Sergey provided a very interesting experiment allowing to realize in a practical way a principle of the heat pump in electricity, where heat can be supplied from less heated bodies to more heated bodies, so less charged bodies can supply their charge to more charged bodies. So here is the link to my replication of this experiment. If you are interested in energy research, you definitely should pay attention to this work. So now, when it became obvious that inductors is not so simple matter, I propose you to answer the question Sergey had asked with regard to the result of this experiment. The question is, what is the physical meaning of the negative self-induction EMF of any induction coil appearing at the moment of charging a circuit, before the current has not even started its movement? No textbook gives an answer to this question yet. If you know one, please write a comment. The addition to the experiment. So next I want to answer my own question. What will happen if we simply close the circuit and will not interrupt it, leaving the circuit closed? Will received oscillograms help us to define that the diagrams in Sergey's experiment are exactly sign-shaped patterns and not some other curves calculated with unknown formulas? The scheme of probe connection in Sergey's experiment to measure the voltage across the inductor is shown next. This is a photo from the original experiment. You can see the ground, you can see the tip, and how they are connected to the circuit. Using it, I constructed a system literally in 5 minutes with parts that I have on my table, for to show that to do this experiment is very easy. So how it was in my case, you can see an inductor from fluorescent lamp, battery, capacitor, oscilloscope, and that's all you need to replicate this experiment. So next is the scheme of my system and oscillograms in the scale of 20 milliseconds and 5 milliseconds. This is my scheme, it's the same, and this is my results. So this point I called stop. The green line labeled stop shows the place where the relay interrupted the circuit in the original experiment. My result matched Sergey's oscillogram very well. So this is oscillogram from the original, and this is my oscillogram. It's the same. Sergey in his video told that even we will do all the mathematical physics, the physical meaning of this effect remains unknown, and inertia of any inductor is not something ephemeral, but manifests itself exactly in this phenomenon, this appearing of kind of negative energy that needs to be compensated by the energy of the power supply in the first 1/4 of the period. The question arises, what is it, this appearing negative energy, and how it appears? So if you are working on the fuelless generators, especially electromagnetical generators, you definitely should answer this question for yourself. What will happen if we change the point of reference to the source negative terminal by placing the oscilloscope ground to it. So I simply change the ground to the minus of the battery to see the results. So results is here. You can see the DC of the battery, and then this is a place when self-inductance EMF and the EMF of the battery cancel each other, and then slowly oscillations begin. So next I want to show the video how it has been done. So here is a video from my Russian replication. Let's see. I show the diagram, how oscilloscope is connected. Then I change the scale to something about 1 or 2 seconds on the oscilloscope timeline. Now it is showing the level of battery voltage, some about 3.5 volts. Here I discharge the capacitor fully, and this here I manually close the circuit and get this spike on the scope, stop it, and scale it to see what is a picture. And we can see the same result as in diagrams. Here the self-inductance EMF manifests itself, cancelling the EMF of the battery, and then oscillations begin. So let's continue. What will happen if now we place the probe tip in a way showing the condition of the capacitor plates? So I replace the tip of oscilloscope here, and the results is this. So you can see the capacitor charge itself to the double the source voltage. Then it began to oscillate, and oscillation is damping, and finally the voltage is equal to the source voltage, but in the first moment it is doubling the voltage source. And this is another scale to see that this is exactly the sine-shaped pattern. It's found that besides oscillating discharge of a capacitor, there exists kind of oscillating charge, or how to term it, how to call this process. I'd like to call it oscillating charge. So we can see the next video. This video shows us another connection to see what's happening across the capacitor. So the setup is the same. The voltage you can see is 0. And now I manually close the contact at the top of the screen. Firstly, I discharge the capacitor fully, then I touch the contact, and receive some spike on the oscilloscope. Stop it. Change the scale. And you can see in this video we could see that we could get another interesting effect where if we close the circuit not after full discharge of the capacitor, but at some moment of its discharging through the oscilloscope in DC mode. Here is a series of closing the circuit from different levels of the capacitor discharge. So you can see closing 1, closing 2, 3 and 4. With number 1 it's closing from fully discharged capacitor, number 2 from the level of 3 volts, number 3 from 2.6 volts, number 4 from 2 volts. So the oscillograms of this charging, and you can see that the amplitude of this oscillating charge is different. What is the meaning of the relation between amplitude of the oscillating charging and the level of the capacitor voltage from which closing the circuit is done? And what about the current in the circuit? This is the scheme from the original Sergey experiment to measure the current. with relation to the voltage across the inductor. So next is my scheme I used for this measurement. So I put some resistor with very little resistance, not to interfere in the process in the circuit, and you can see the voltage across this resistor, showing us indirectly, but it shows us the way current is moving in this circuit. So next the video. So here is a diagram of connection. How to measure the current. Some explanations, and you can see a resistor. I pointed with the mouse on the positive terminal. So now I checked the voltage. So the current through the resistor with a short circuit battery it was. Now I change the scale of voltage, discharge capacitor, and manually close the circuit. And received a little spike. Stop, and then change the scale to see in more detail what we get. So you see in this picture and the same as in diagrams. Conclusions. All the oscillograms that I received in my own replication match the oscillograms in Sergey Deyna's original experiment. A year ago and now, with another setup, they are the same. No wonder Sergey called in his comments this experiment being kind of a riddle. I agree with him. There is much more than simply pay attention to this effect. If you are at the beginning of your electronic research experience, by replicating this experiment, you will learn many useful practical aspects, and the most important, you will begin to check the information given in textbooks and make your own understanding of how really elements work. I hope this work will allow you to dive deeper into the process in serious LC tank to feel them, or at least I suggest the way to it. Wish you all the inspirations in replicating experiments.